This video is produced by Sammy and
Kevin Burgess
for by Inquisition Press to support the workbook Sophomore Organic Chemistry 2 by Inquisition, available from www.byinquisition.org.
Transfer of acyl groups is important, and nature does it by forming things like acyl phosphates and acetyl-CoA, in other words, a thioester. Acylation mechanisms are pH dependent. Under basic conditions, a nucleophile can just add to form a tetrahedral intermediate, and then loss of a leaving group will give you the acylation product. So we've transferred the acyl group to the nucleophile. Ethanol chloride, for instance, will react with hydroxide to give a tetrahedral intermediate. Chloride will be lost, and the product will be
Ethanoic acid.
ethanoic acid. Good. Under acidic conditions, the first step is always to protonate the carbonyl first, and then the nucleophile may add. Now here it's shown as an anionic nucleophile. That can only happen if the nucleophile is very non-basic. So the anionic nucleophile can add, a leaving group leaves, and then finally deprotonation gives you the acylation product. So let's look at a really hot acylating agent, an acyl fluoride. Hot means reactive. If a nucleophile adds to an acyl fluoride very quickly, will form a tetrahedral intermediate and the fluoride will be lost. Under acidic conditions, however, a reactive acylating agent like an acyl chloride will often be protonated, react with the neutral nucleophile, give a tetrahedral intermediate, which after loss of a proton and then loss of a leaving group will give you the product. Acyl halides are very reactive electrophiles. Anhydrides are almost as reactive because the leaving group after formation of a tetrahedral intermediate will be a carboxylate, quite a good stabilized leaving group. Under acidic conditions, the anhydride will be protonated to increase its reactivity, addition of a nucleophile, loss of proton, and then finally loss of a carboxylate will give the product. Compared with acyl halides and anhydrides, how reactive are esters? They're not very reactive, yeah. It's still possible, though, to add a reactive anionic nucleophile under basic conditions to give a tetrahedral intermediate and then lose an alkoxide to give the product. And definitely possible to protonate esters, add neutral nucleophiles, proton loss, and then loss of an alkoxide again, which gets protonated immediately, will give you the acylating product. In the body, we don't have acyl halides, and we don't have acid anhydrides, and sometimes esters are not reactive enough. So nature will often use what?
Thioesters.
Thioesters. Thioesters are a little bit more reactive than normal esters. Amides are very poor acylating agents, and the reason for that is under neutral conditions, the leaving group would be NH2-, and that's not a good leaving group. That's a strong base. Under acidic conditions, we can protonate an amide on the carbonyl, add a nucleophile, and then transfer a proton some of the time in a reversible reaction to the NH2, which is lost to give us the acylation product. It's possible under acidic conditions, it's possible under basic conditions, but not very easy. These are not very reactive. And how about carboxylic acid, Sammy?
They're not acylating agents.
No, they're not, because if you add a strong base, what happens?
It just becomes a carboxylate.
Yeah, and so a nucleophile which is negatively charged or electron rich will not like to add to a carboxylate. That's one reason. And the second reason is, let's say we did add a nucleophile, then the intermediate here is a dianion, and to make that O- leave, we'd have to generate O2- as the leaving group. That's never going to happen. We've learned that acyl halides are excellent acylating agents, amides are inappropriate, anhydrides are excellent, acids are inappropriate, and then incidentally, acyl cyanides are excellent acylating agents. If we have to rank the reactivities of acylating agents, always choose the extremes first. So the most reactive one in this series would be
Chloride.
Yeah, the acyl chloride. And the least reactive one would be
O-.
giving the carboxylate. Then fill in the extremes. So second most reactive is the anhydride. Third most reactive would be the ester from phenoxide. The fourth would be the methyl ester. And just a little bit better than the carboxylate would be the amide. In this series here, can you pick out the best one for me, Sammy?
Benzoyl chloride.
Very good. Benzoyl chloride is the most reactive one. And the second one...
The anhydride.
Yeah. What's the least reactive one?
The carboxylic acid is the least reactive one.
And the third most reactive will be the strained ester, because it's got a lot of energy to pop open. The unstrained ester, the acyclic ester, will be the fourth, and the amide will be the fifth.